Hi everyone, welcome to Maths video class 6th and we are on chapter 18 and now we'll see algebraic expression, right? An algebraic expression is a collection of one or more terms which are separated from each other by the sign plus or minus sign. So in algebraic expression the terms are separated by plus or minus sign. So algebraic expression is 5. Number of terms used here is 1 and terms are 5x. Here 8xy square, number of terms used is 1 and terms are 8xy square. 3x plus 8z, 1, 2. Number of terms 2 and terms are 3x and 8z. Okay, 4x minus y plus 7. 4x, 1, 2, 3 and the terms are 4x, y and 7. Okay, so 7xy, 1, 2, 3, 4. Total 4 terms and the different terms are 7xy, 2a upon y, 3z and 8. Okay, so this we have seen in last video also. Now types of algebraic expression. So since we have seen it in last video, we are not seeing it in much details. Okay, so types of algebraic expression. Now types of algebraic expressions we will see. First is monomial. An algebraic expression with only one term is called monomial. Now you know what are terms. So if this kind of examples are given, minus 8 z, xy, 2x, 5y, 2x upon 5y. These are all monomials. Now binomials, an algebraic expression of two unlike terms is called a binomial. Okay, an algebraic expression of two unlike terms is called a binomial. Now 5x plus 2y is a binomial because these two are unlike terms. 7 minus x, 4x plus y, y plus 7 zy. Means here only one term is there, here two unlike terms are there. So 1, 2, two unlike terms. Unlike terms means which do not have same kind of variables. Trinomials. An algebraic expression containing three unlike terms. An algebraic expression containing three unlike terms is called a trinomial. So, 1, you can see the example 1, 2, 3. Now, all the three terms are unlike terms. Now, you must be thinking why it is not like terms if three like terms are there. If three like terms are there, then you can add them and it will become one term. Okay, for that purpose, three unlike terms are called as the algebraic expression containing three unlike terms is known as trinomials. 1, 2, 3, 1, 2, 3, 1, 2, 3. Multinomial. An algebraic expression with two or more than two terms is called a multinomial. Two or more than two terms. 3, then trinomial. Two or more, then they are called as multinomials. You can see 1, 2, 1, 2, 1, 2 terms. Here 1, 2, 3, 4 terms. Here 1, 2, 3, 4, 5 terms. So when two or more than two terms are there in an algebraic expression, it is called as multinomial. Even trinomial is a multinomial because it has two or more than two. Even binomial. Then polynomial. An algebraic expression with one or more unlike terms is called polynomial. So an algebraic expression with one or more means what? All these monomial, binomial, trinomial, multinomial are all polynomials. Okay, so an algebraic expression with one or more terms is called polynomial. Examples we'll see. Each of minus 20, 8x, 5x, 3xy square is a polynomial. 3x plus 2y is polynomial with two terms. 1, 2, 3, 4. This x plus 4yz minus 7z plus 8 is a polynomial of 4 terms. Okay. So every monomial, every binomial, every trinomial and every multinomial is a polynomial. Okay. So for each literal used in polynomial, its power must always be a whole number. A polynomial cannot be of the form 1 by x, 3 upon 3 x plus 5, 2x upon x minus 5, 5. So these types you can see it is not allowed for terms. for polynomial it is not allowed. Okay, and this for each literal used in the polynomial, its power must always be a whole number. This thing we'll see while studying degrees. Alright. So, terms are separated by, we have seen that the terms are separated by plus or minus signs only. The signs of multiplication and division do not separate the terms. They unite them. Okay. So, thus 3p plus 5z minus 7y has 3 terms, whereas 3p multiplied by 5z minus 7y has only 2 terms. See, this is first term and this is second term. This is one term and this is second term. Because 3 5s are 15, 15pz minus 7y has only 2 terms. Okay. Now products and factors. A product is a result of multiplication of 2 or more constants or literals or both. So, when I multiply any two numbers, any one constant with other variable, I get the product. For example, 5xy is the product of 5x and y. So, when I multiply 5 with x and 5 multiplied by x multiplied by y gives me 5xy. Okay. And so 5xy is a product and 5 comma x and y are called as factors of that product. Factors of that product. Okay. Now let us see coefficient. Any factor or group of factors of a product is known as the coefficient of remaining factors. So any factor or group of factors of a product is known as coefficient of the remaining factors. What does it mean? When I have 5axy, what is the coefficient of 5? The remaining factors will be coefficient of 5. So axy is coefficient of 5. Now what is the coefficient of a? Coefficient of a is the remaining 3 factors 5, x and y. Similarly, the coefficient of y are 5, a and x. Now sometimes only numeral coefficient is asked. Numeral means number. Numeral means number and literal means alphabets. So what is the numeral coefficient of x? So numeral coefficient means number. We are talking about the numeral coefficient. So numeral coefficient means number. So 5 is the numeral coefficient of x here. Okay, not all you have to write. If a factor is a numerical quantity, it is called numerical coefficient of remaining factors, and if the factor involves letters, it is called literal coefficient of the remaining factors. If the literal coefficient is asked of x, so what are the literal coefficient of x? A and y. Literal means alphabets. So literal coefficients of x are a and y. Literal coefficients of y are a and x. Why? Because only literal coefficients are asked. Okay. So numeral and literal, that you have to understand. And when the coefficient is unity, that is 1, it is usually omitted. That is 1b is written as b. So if I want to write a plus, if it is a plus b, means it is 1a plus 1b. But we don't write 1a, we write only a. If it is 2b, then okay. But if it is only b, then we have to write b. It means 1b, we have to consider as 1b only. Alright. Now, power of literal quantities. When a quantity is multiplied by itself any number of times, the product is called a power of that quantity. This product is expressed by writing the number of like factors in it to the right of the quantity slightly raised. Means, if a quantity is multiplied by itself many times, the product is called the power of the quantity. Means, here a is multiplied with itself many times. Many times means here in this case 2 times. But if you will see other cases, here 3 times, here 5 times. So, a multiplied by a, you have to write a square. This is square. We have to read it as a square or a to the power 2. This is the power. Now a is multiplied by itself 3 times. The product will be, after multiplying, what do we get? We get a cube. This is called as cube. So a into a into a. A is multiplied by itself 5 times. 1, 2, 3, 4, 5. So a into a into a into a into a. 1, 2, 3, 4, 5. A raised to 5. Okay. So a raised to 5. Now, so you can see here example, a multiplied by a is a square. It is read as a squared or a raised to the power 2. A multiplied by itself 3 times, so a cubed or a raised to the power 3. M multiplied by itself 5 times, so m raised to 5, we have to read it as m raised to the power 5 or fifth power of 5, right? So in all the cases, a is base and 2 is index, or we say power. Okay, so a is called base and 8 is called this example is given a raised to 8. A is called the base and 8 is called the exponent or the index or the power. So this here square, here 3 and here 5, they are known as index or power or exponents, and here a and m are called as base. Okay, so example, you can see 1 2 3 1 2 m into m into m square, n taken 4 times, so n raised to 4. So 3 as it is, 3 b. See, b is to be written. See this, how many times b have come? 4 times. So b raised to 4 and p raised to 3. 1 2 3. Okay. Now the next important topic we are going to see is polynomial in one variable and its degree. So when an algebraic expression is made of one variable only, it is called a polynomial in one variable. Okay. So here you can see this is the polynomial with one variable. Why? Because only one type of variable is used, x, and x is used here. Okay. So we say that this is polynomial with one variable, and y means what? Here both y's are used. So we say that this is polynomial in one variable. Okay. Now sometimes you might have seen 3x plus 5y plus 2z. What does it mean? X, y, z. 3 different kind of variables are used here. But if you'll see these cases, only one kind of variable is used, x and x. Here y, y. What does it mean? That these are polynomial in one variable and these are polynomial in different variables. Okay. Now let us see the degree of a polynomial. The degree of a polynomial in one variable is the greatest of the exponents of its various terms. Now in this case, let's see same example. In this we have 3 terms. Now in these 3 terms, which term has the largest number of exponent, or which term has the largest number of exponent? So here you can see there is no degree, means there is no exponent or index or power. Here x has 1 and here x square means 2. So out of 0, 1 and 2, which is greatest? 2 is greatest. So we say that the degree of this polynomial is 2. Okay, in these 3 things, in these 3 terms, you can see here 3, 2 and here 0. So 3, 2, 0, which is highest? 3 is highest. So we say that 3 is the degree of this polynomial, right? Now let us see here few examples are there. 25 minus x raised to 4. Here 0 and here 4. Here nothing is there and here x raised to 4. So 4 is largest. So we say that 4 is the degree, right? So now one more example we'll see here. X raised to nothing is there, means x is taken only one time. So 5x minus 3, 1 is here. So 1 is the only degree. Okay. In this case you can see 1, 2, 3. In these three terms, x index is 3. X indices are 3, 5 and 8. So which is greatest? 8 is greatest. So we say the degree is 8. Now we'll see the polynomials of 2 or more variables and their degrees. Okay. So we have seen polynomial in one variable, and now we'll see polynomial of different variables or polynomials of 2 or more variables. So here you can see x is there, y is there, z is also there. So 2 or more variables polynomial it is. So x, y and z. So polynomial made of 3 variables x, y and z. Here also y, x. So two variables are used here. Y, here x, y, x. What does it mean? These are polynomial with 2 variables. These are polynomial with, this is polynomial with 3 variables. Sorry, this is the polynomial with 3 variables, and this is the polynomial with 2 variables. Here x, y, z and here x, y. Right? Now how to find its degree? Let us see. This, how to find its degree, we will see in the upcoming exercise. Okay, that is exercise 18b, and in the next video. Right? So please read this chapter, understand. Okay, if you have any doubt, you can contact me. Thank you so much, and please take care.